Radio frequency environments are inherently complex and therefore challenging to control and optimize for the efficient transmission of data. Since the inception of radio frequency, or RF radio resource management, also known as RRM, has been a long-standing technique used to optimize the RF radio waves that transmit network traffic in wireless LANs. However, multiple interference sources like walls, buildings, and people, combined with the air servings of transmission medium, make RRM a challenging technique to master. Traditionally, site surveys have been used to determine the optimal placement of Wi-Fi access points and settings for transmit power, channels, and bandwidth. However, these manual approaches can account for the dynamic nature of the environment when the wireless network is in use, with people and devices entering or leaving and moving about. Additionally, this challenge is compounded with random RF interference from sources like microwave ovens, radios, and aircraft radar, to name a few. But what if the wireless network itself could perform RRM on its own? What if it could detect and respond to both interference sources as well as the movement of people and devices and adjust the radio settings in real time to provide the best possible wireless service? That's exactly what Juniper's done with the AI-native Mist wireless solution. Using advanced machine learning techniques, specifically misuses reinforcement learning to perform RRM. In a nutshell, a reinforcement learning machine, or agent, learns through an iterative trial and error process in an effort to achieve the correct results. It's rewarded for actions that lead to the correct result, while receiving penalties for actions leading to an incorrect result. The machine learns by favoring actions that result in rewards. With Mist Wireless, the reinforcement learning machine's value function is based on three main factors that lead to a good user experience: coverage, capacity, and connectivity. A value function can be thought of as an expected return based on the actions taken. The machine can execute 5 different actions to optimize the value function. These are adjusting the band settings between the two wireless bands of 2.4 GHz and 5 GHz, increasing or decreasing the transmit power of the AP's radios, switching to a different channel within the band, adjusting a channel's bandwidth, and switching the BSS color, which is a new knob available to 11 AX access points. RRM will select actions with maximum future rewards for a site. Future rewards are evaluated by a value function. The various actions taken by the learning machine, such as the increase of transmit power or switching the band from 2.4 gigs to 5 gigs, together represent a policy, which is a map the machine builds based on multiple trial and error cycles as it collects rewards modeling actions that maximize the value function. Again, keep in mind that the value function represents good wireless user experience. As time goes on, even if random changes occur in the environment, the machine learns as it strives to maximize the value function. The benefits of using reinforcement learning are obvious. A Mist wireless network customizes the RRM policy per site, creating a unique wireless coverage environment akin to a well-tailored suit. While large organizations with multiple sites replicate their many locations as copy exact, these sites will naturally experience variances despite best efforts. Reinforcement learning easily fixes this, delivering real-time, actively adjusting custom wireless environments. We hope this episode helped to uncover some of the magic and mystery behind our AI native network solutions.